In healthcare, time is not just money. Time is life. Yet, we spend countless hours on manual triage, repetitive data entry, and disconnected systems. The process between patient arrival and medical care is fundamental, but it is often a bottleneck or simply inefficient. To solve this, we created ANA. I'm Victor. Together with Flavia, Gabriel, Murilo, and Robson, we developed the ANAmnesis project. So, let's see how ANA works. First, the patient authenticates on screen by entering their name and CPF.
What is your date of birth?
February 26, 1987.
ANA features voice recognition, so the patient talks and listens to the totem during this whole step.
What is your height?
I'm 172.
What is your weight?
I'm 77 kilos.
What is your occupation?
I'm a football player.
After gathering basic information, the totem measures vital signs: temperature, blood pressure, heart rate, and oxygen saturation.
Put your finger on the oximeter as shown on the screen. Remove the finger from the oximeter.
ANA will now measure the patient's blood pressure. After that, she'll perform an intelligent interview based on the patient's response.
What brings you here today?
I think I broke my knee.
How did this happen?
I was playing football and I got kicked on the leg.
Which knee was injured?
Left knee.
Are you able to put weight on your left leg?
No, I can't walk.
Do you notice any swelling or bruising around your left knee?
Yes, both of them.
Did you hear any popping or snapping sound at the time of injury?
Yes, I heard a loud snapping noise.
Is there any visible deformity of your left knee?
No, there is not.
What is your current pain level on a scale of 0 to 10?
I think 7.
Thanks for the information. You can leave now.
Let's see how it generates different questions in a different case.
What brings you here today?
I was bit by a spider.
When did this happen?
Today, in the morning.
Where on your body were you bitten?
I was bitten on my foot.
Repeat.
I was bitten on my foot.
Does the bite site look like?
It's very red and hot.
Now, moving over to the website. On the main page, we see a list of every single patient that has an open report on the system. If we type on the search bar, we may search for a specific patient and then see a list of every single report that this patient has registered. If we choose one and click on View, we can see all of the information that was collected during the screening process, such as sensor information and the questions that the patient answered, including the interview, which has the dynamic questions. Up here on the top right, we have a button that essentially allows us to export this data as a PDF file for better storage and filing.
Talking a bit more about the technical details, the Totem chassis is made from laser-cut MDF wood. Also, there are some hinges and 3D printed pieces for the moving parts. The system is powered by a Raspberry Pi 4. It acts as the central controller, managing high-level logic and user interface. Also, Raspberry is responsible for audio input and output. The Totem has a microphone and a speaker for communication. The speech-to-text is processed using a VOSC model, and the text-to-speech is processed using Piper. Both of those run locally in a separate server. The Raspberry also runs a service that connects to Gemini API, which generates the dynamic questions during the anamnesis and processes the patient's responses. It communicates with the NASP32, which handles the low-level hardware. It controls the servo motors, the sphygmomanometer, and reads data from the oximeter and temperature sensors. Finally, there is a camera connected to the Raspberry Pi. It takes a picture of the sphygmomanometer display and uses optical character recognition to extract the blood pressure and heart rate values. When the anamnesis is complete, It sends all data to the report server, which stores the information in a database and serves the website where medical staff can access the patient's reports. This concludes our presentation for ANAmnesis. Although this prototype is not yet ready to replace human care, we achieved promising results that demonstrate its potential for future hospital implementation. It was a challenging project to execute, especially considering the complexity of integrating so many different hardware and software modules, but overall it successfully fulfills the requirements we established. Thank you for your attention.